Welcome to this month's Access Control Coaching session. My name is Cole Nebeker. I am the Training and Events Manager for PDK, and this month we are going to be discussing site design and how to simplify and improve your installation process. So, before we begin, be sure to hit that subscribe and bell icon so that you don't miss any of these future videos. We have some really good videos coming up in the coming months. So, let's go ahead and jump right into it. So we're going to start here with the overview. We're going to begin with our 5 necessities. These necessities, as I'm going to explain later, are going to be the 5 components, the basic families of components that we will need in order to design a proper site. We'll then get into the topography, which includes your head end, your controllers, your communication methods, your readers, credentials, and peripherals. And then we will finish this presentation with our best practices, and we will have a live exercise, a pop quiz, if you will. So, beginning with our necessities, number 1, of course, is going to be our head-end unit. You do need to have a head-end unit per site. Now, it is possible that you may have more than one head-end unit. This head-end unit is going to be the cloud node, and we'll cover the different varieties of those when we get to the topography. But this will determine your mounting positions as well as your communication protocols that you'll be using on site. Once you have your head-end unit squared away, we're going to move into the controllers. And the controllers are going to be the actual controlling units of the doors. So we will, of course, need to have as many controllers as we have doors. Regardless of how many doors you may have a single controller, or you may have dozens or even hundreds of controllers. These also are dependent on the communication methods that we use. Our third unit is going to be our readers, and the readers are going to be the most customer-facing component of the system and probably the most interacted with, so these are a very important component. These will determine the technologies and security levels of your on-site equipment. We also have our credentials, which are not to be neglected. That is the method you use at the reader to get through the door. Without credentials, you won't be getting through any doors, so you need to make sure that the credentials you spec are going to be compatible with the readers and meet the client's needs. And then finally, we have peripherals, which are going to be extra components that can simplify your access management on site. In other words, they are going to be extra components, maybe necessary for egress or for improved communication. So, for our topography, we have PDK.io, the software. We're not going to be covering really anything about PDK.io in this session because we are working with the on-site equipment for the site design piece. But we have our cloud node, which is going to be the head-end unit, and we have a couple of different models of that. We have the controllers, which include the Red 1, Red 2, Red 4, Red 8, and Red Max. Also not to be forgotten are the Red Pedestal and Red Gate and the Aux 8, which does not appear on this slide. So each of these are going to be different size controllers. We have the Red 1, which is a 1-door controller. We have the Red 2, which is a 2-door, and so forth. The Red 8 is an 8-door. The Red Max is customizable up to 24 doors worth of controlling. So, which one of these we use, we're going to discuss in a future slide, but as kind of overview of it is going to be dependent on whether we install as an edge application or a centralized application. Each of these are going to communicate in different ways. We have Ethernet and PoE, which are hardwired. PoE, of course, providing power to the controller as well as communicating. And we also have wireless. So the wireless is going to remove the need to run a wire from a switch or a router all the way out to the door controller. We can instead just utilize the Zigbee protocol built into the cloud node to communicate out to that door controller. So you'll notice once we get up to the Red 8 and Red Max, those are typically more centralized. Those are going to be hardwired rather than wireless. So starting with the cloud node, a breakdown of the different types, we have the RCNE and the RCNEW. Those are the part numbers. They're very complex. It stands for Red Cloud Node Ethernet and Red Cloud Node Ethernet and Wireless. Try to remember that. Try to keep up. So we have got our Ethernet only one, and we have our Ethernet and wireless one. We are going to have, both of these have the single door controller built into them, and they have sufficient space in the bottom for an 8 amp hour battery. These are wall mounted, and they're typically just installed in some sort of an IT closet, typically pretty close to the router, but it can be mounted a little more remotely if you need to use the onboard controller to control one of your doors. We also have the RSVR, which I neglected to put in this presentation, which is going to be your rack mountable cloud node. It's a 19-inch rack mount. It's Ethernet only, and it does not have a built-on single door controller. It is just designed to be mounted in a rack. So that is going to cover our head ends. Now getting into the controllers, we have the Red 1. You can see the communication protocols, the default's Ethernet. We have PoE capabilities, and we have wireless capabilities. All of these door controllers are going to support either Wiegand or OSTP communications. We will cover that when we get to the readers, or if you are using a third-party reader, you can of course tie those in if they support those protocols. These fit those big 8 amp hour backup batteries in the bottom. And you can break down the capabilities of each of these door controllers by what they have per port. So we have one reader input per port. We have one A input and B input. The A input is for your DPS, the B is for REX, and we have one relay, and the relay can either be a wet or a dry. In other words, it can be powered or it can be unpowered. If we go to the Red 2, it is going to be a continuation of this. It just has 2 ports, so it has 2 reader ports, 2 A inputs, 2 B inputs, and 2 relays. I guess I neglected to mention that each of these also has a battery lead and a power input. So you can power up your backup battery and power the board if you are not using PoE. And if we go to the Red 4, this is just, again, a continuation. It just has 4 ports. So each of the Red 1, Red 2, and Red 4 can be Ethernet, which they are by default, or they can be PoE, or they can be wireless. The aux8 is a little more interesting because this doesn't conform to the typical reader input, A input, B input, and so forth. This has 8 ports, and each port simply has 1 input and 1 output. So that means that you can tie in up to 8 inputs and 8 outputs, or one or the other. So these aux8s are typically used for things like door monitoring, or elevator controls, or alarm controls. It also has a pretty significant power output. I believe it's about 0.5 amp per port, if I remember correctly. And it is going to be very versatile. It works just like a normal door controller, but without the reader inputs. It's just designed to receive inputs and trigger outputs. The Red 8 is going to have, it's going to be the first to have a built-in power supply with the Altronics eFlow 102NB. And it has pretty good space in the bottom for some backup batteries as well. It is just 2 4-door controllers, which provides you a total of 8 ports. And we are once again reverting back to the 1 reader port, 2 inputs, and 1 relay per port. So multiply that by 8, and that is how much you have with the Red 8. And finally, we have the Red Max, which comes from the factory, and this is very important. It comes from the factory with 8 doors of capability. It does not come with the 24. So you see in this picture, it shows a system fully spec'd out with all 24 doors of controls inside of it. But when it comes from the factory, it's only going to have 2 of those Red 4s. You will need to populate the rest, which is why we advertise it as 8 to 24 doors. It can be 8, or it can be 10, or it can be 16, or it can be 22. It's between 8 to 24 doors. It's a very customizable enclosure. Now we provide 2 of those eFlow Altronics power supplies inside of there, and then you just spec out the rest. You get our expander boards, which we have the R1E, R2E, R4E, and the A8E, which is going to be that aux8 controller. And you mix and match to meet the total number of doors that you need. We have the Red Gate. The Red Gate is a 2-door controller. So it's designed for scan-in and scan-out applications. It's in a NEMA enclosure, a plastic NEMA enclosure. It's typically mounted out of sight and out of mind. It's not forward-facing, customer-facing, I should say. It's a pretty small enclosure. It only fits a 1.2 amp hour backup battery inside of there. So keep that in mind. You're not going to cram an 8 amp hour battery inside of there like you do with the rest of them. That said, it is typically mounted somewhere, maybe up on a pole or on a fence. What I've seen a lot of when I've helped people with site designs is they kind of tuck it into the plastic casing that covers the gate motor. They just mount it really close to the gate motor itself, and in that regard, it's just kind of tucked out of mind. But it is weatherproof, so you can mount it directly outdoors, and this one can be Ethernet or wireless, and it can be expanded with that PoE module. The pedestal, very similar, just a different enclosure. This is also a two-door controller. It's designed for scan in and scan out at a gate. This one, though, is a steel enclosure. So it is not going to be kind of tucked out of sight and out of mind. This is a very premium enclosure. You're going to want to show all your clients this thing. So you put it out on the gooseneck. It has the mounting pattern on the back for a gooseneck. And once again, a smaller enclosure. It's a little more compact. So this is going to have the 1.2 amp hour backup battery. But again, it can be Ethernet or wireless or expanded into PoE capabilities with that PoE module. Now this screen shows you the communication methods. You may have noticed that all of the previous slides showed an Ethernet as the standard piece of equipment, and that's because everything ships from the factory. Well, let me clarify. All the door controllers, with the exception of the cloud nodes, the gate controllers, and the pedestals, ship standard from the factory as Ethernet by default. You can expand those using these modules into PoE or wireless capabilities. So we have a red 2 here on our screen. If you do the PoE capabilities, you will buy the RM PoE, stands for Red Module PoE, and that will provide either PoE, PoE Plus, or PoE++ power to your device. It depends on what kind of switch you use. It will automatically adapt and provide that power to the door controller. So if you use PoE++, that'll give you up to 3.5 amps of power, so it's important to take into consideration the power requirements of the system you're using. The wireless module is the RMW, stands for Red Module Wireless. This is going to be another chip that you just snap onto the board, provides an advertised 1 mile line of sight, 450-foot average. I want to really clarify here that you should always use a range test kit. You can reach out to your salesperson. They will get you set up with a range test kit because interference with wireless is a very real thing. So don't go into any job site just assuming that the 450-foot indoor range is going to be suitable for your application. Make sure you test it first. So this shows you a typical Ethernet setup. Or a PoE setup. You can see here we have a cloud node installed somewhat centrally next to a switch because the cloud node itself always has to be plugged into Ethernet. So the cloud node's plugged into that switch, and then that same switch is plugged into several door controllers. You can see for the right-hand side of my screen, we have the Red 4, which is installed again somewhat centrally, and then presumably banana cable is run out to each of those 4 doors to control them. Alternatively, you could just run Ethernet to each of those 4 doors and do a Red 1 above each of those doors. Then we have a secondary switch, which is controlling another 3 doors. This kind of gives you the idea of what we're looking at with Ethernet. You just run cat cable wherever you need. Don't forget that cat cable only goes 100 meters, about 300 feet. So you'll need to take that into consideration. Now, when we are putting these above doors, it will look something like this. We have the cloud node, which we just assumed in this case was an RCNE, but you could use the RCNEW. The RCNEW does have wireless capabilities, but it still communicates locally on Ethernet just fine. That is connected to the switch, and by proxy, it's connected to the cloud. Now we need to connect the door controller to that cloud node, and we do that by plugging it into some switch on the system. This one shows the exact same switch, which is totally fine, but as long as the switches are connected on the same subnet, you're going to be totally fine. Then we have our controller, which is connected to all of the door's hardware, which includes the REX, the DPS, the reader, and the lock. Again, each port on a controller has one reader input, one A input for DPS, one B input for REX, and one relay for the locking mechanism itself. Now, if we choose to do wireless after we have done a range test kit, we can install a cloud node centrally, which is connected to a switch. It doesn't show it on the screen, but the cloud node, again, requires an Ethernet connection. And then it is broadcasting and creating a mesh network connection with all the wireless controllers. Now, these controllers are not Wi-Fi. This is a proprietary wireless. It is a Zigbee protocol. Now, if you know anything about a Zigbee protocol, it creates a giant mesh network. So you can see on the far right there, we have a couple of doors that are actually not directly connected to the cloud node. They are one controller away from the cloud node in both directions. So those door controllers are bouncing off of a different controller back to the cloud node. This means that if you have a particularly large site that needs to do wireless, the signal becomes even stronger because it can follow the path of least resistance all the way back to the cloud node itself. Wiring these is identical with the exception that you do not need to run a CAT cable between the switch and the controller. The cloud node is just producing a signal and communicating with the controller via wireless. All right, now we're going to change gears a little bit. We're going to get into the readers. So if you remember back to those necessities, we have now covered the cloud nodes, either the RCNE, RCNEW, or RSVR. We've covered the controllers, of which we have covered all of those. Now we need to get into the readers, and these are going to determine the technology that the client can use on site. Now this is a basic breakdown of our different kinds of readers. We have the high security, in other words, the red readers. We have the Touch I/O, which is a Bluetooth reader. We have the rugged readers, which are just the most robust and vandal-proof readers that we have, and we have our standard readers. This shows you a brief breakdown of the different technologies inside the readers. I'm not going to go in much depth on this page. This is more of a reference for your benefit. If you do need this, you're welcome to take a picture while I blabber on here for a minute. But this shows you the different technologies, capabilities, weather resistance, voltage inputs, amperages, and technologies and sizes of the readers. So all of the part numbers for the readers are there on the left. We're starting with the standard readers up top. We have the rugged readers below that. We have the RDR-BT, which is kind of a one-off. That's just the Bluetooth reader. And then the bottom 12 are all red readers. They are indicated by either an RM, RG, or RK status. So you just build on those part numbers until you have all the technologies that you would like to include. So, for example, the red mullion, the RM, that is all of these red readers come with high security. So the RM is simply a high security mullion style reader. You can see beneath that we have the RMP. So that is a red mullion with prox. That P stands for prox. So that just means that not only do we have the high security, we also have prox capabilities. So if you have kind of a hybrid site. We have the RMB, and that B stands for Bluetooth. So that is a red mullion reader with Bluetooth capabilities. No prox, just high security and Bluetooth. Then we finally have the RMPB, which stands for red mullion with both prox and Bluetooth. And that means that it has high security, prox, and Bluetooth capabilities. You just rinse and repeat for the RG and the RK as well. The G stands for gang size, so it's a wider reader, and the RK is the keypad style of the red reader. It is also a gang sized. The ones above, we will kind of go over their different capabilities here in just a few moments. Getting started with the red readers though. We have those 12 different varieties. They're designed for high security environments. Each and every one of those red readers has high security components. And what that high security means is that it has the OSDP and it has the 13.56 megahertz smart cards. So any red reader will support both Wiegand and OSDP. I would argue that if you are ever using a red reader, you should always, always, always use OSDP. That is the shining moment for the Red Reader is to utilize all of its high security functionality. And then when we build on either the prox or the Bluetooth or both, they come with the prox and Bluetooth capabilities as well. Now these come in either a mullion sized or a gang size. Those are the three models up there on the screen. We have the mullion in the middle, the gang size to the right, and the keypad on the left, which is also the same size as the keypad, or I'm sorry, the gang size. And all of these have IP55 weather ratings. All of PDK's readers are outdoor rated, which means that you can use any one of them outdoors. Now, will all of them survive being submerged underwater? No, probably not, but they will all withstand the basic weather elements that you can throw at them. The Touch I/O is either mullion or gang. The Touch I/O is actually the only PDK reader that is either mullion style or gang size. It just comes with a backplate that can transform it from this skinny format that you see on the screen into a gang size format. This can be indoor or outdoor. It's designed for mobile-ready facilities. This reader coincidentally came out roughly about the same time that COVID hit, so we've always advertised it as a health-friendly device, which it is. It's designed to be touchless. It has a motion sensor inside, so you just wave your hand in front of it, and it can open and unlock that door for you. That was very good timing on our part. So the specifications is we have the Wiegand communication and the 26-bit prox. This one is Wiegand only and 26-bit prox, so this will be used likely in conjunction with PDK's prox devices. The backplate, as I mentioned, is either, if you leave it off, mullion sized, or if you put it on, gang sized, and then this one has a slightly higher weather rating at IP65. The ruggedized readers, I love these readers. They are solid metal and very robust, designed to really withstand anything you throw at them. Their applications, a few ideas of applications, this isn't to limit you by any means, would be some garage doors, gates, outdoor openings. I personally use this on my own home. For the garage door, it's been mounted there for several years. I just think they're good-looking devices, which is why I put in the next point that they are designed for design-sensitive applications. Whenever I see these in an installation, I know that some care was taken to make it a good-looking installation. But my personal feelings aside, some specifications of these, they are Wiegand output, anywhere from 26 to 37-bit prox input. They are IP68 rated. These ones actually will work underwater, so if you do have any underwater facilities in mind, feel free to use these. We have the IK10 impact resistance, so they are, and you guys probably like me were not familiar with the IK10 impact resistance. That's a very impressive and very robust resistance rating. These will withstand quite a lot of abuse. These support anywhere from -4 to 140 Fahrenheit rating. So I apologize to our friends who live in the Great White North. This may not go as low as you may want. But if we go to the next readers, these ones do. These ones can go quite low in their temperature ratings. These are very cost-conscious, very budget-friendly. They're also indoor or outdoor capable. They're an IP65 rating, so not quite as high as the ruggedized readers, but they do go to a lower temperature. These are also a Wiegand output with 26 to 37-bit prox input. All right, so that covers our readers. Hopefully you got a good picture of the slide that covers all the technologies and the amperages and voltage ratings. Now we need to get into the credential types, which are going to be the method that the client uses to get through their doors. So first is mobile. These are going to be, they're all high security. Everything mobile related is encrypted. So we can utilize one of two mobile credentials. We can do the touch credential or the tap credential, where we basically tap and hold to gain access through a door, and we can do the Bluetooth credential. And that is where you present your phone, or in the case of the Touch I/O, leave the phone in your pocket, wave your hand in front of it, and it will grant you access through the door. So both of those are going to be good high security options. I would argue that those are good to have on every site. Now we also have cards and fobs, which also come in high security capabilities. They also come in procs, but we're going to start with the high security. The card is capable of coming in a couple different formats dependent on what you need. So the RC is a typical high security 13.56 megahertz encrypted credential. We have the RC8, and that 8 specifies the memory on board, 8K, 8 kilobits of storage on board. We have the RC8M, the RCP, and the RC8P. That P in the RCP and RC8P stands for procs. That means that it has both high security and procs capabilities. And then that M on the RC8M is for a mag stripe, if you have a facility that still uses those. For our fobs, the high security option is just one. It's RKF, the red key fob. Now for procs on both of these, we have a slightly fewer options. We have CPC, the CSC for the cards. So the CPC is the printable. It's the very thin credential. We have the CSC, which is the clamshell, slightly thicker, a little more cost effective. And then we have the KFC and the LTH for the fobs. KFC being the key fob credential, also Kentucky Fried Chicken, and LTH, which is the leather key fob. So those are going to be your procs options. All of PDK's procs options are 26-bit, and they are 125 kilohertz. All of their facility codes are facility code 77 on those. Stickers, wristbands, these are all procs credentials. The sticker's pretty straightforward. The STK, the wristband is also pretty straightforward. We have the BRC and the WBC. Now the one you see there on the screen is the WBC. That one is stretchy and cloth. The BRC is the one that we've had for years and years and years, and that's a silicon wristband. It comes in a couple different colors, believe it or not: white, black, blue, and red. So you can kind of customize those to whatever the client is requesting. Now that we have credentials out of the way, we need to finally focus on our essential number 5, which is our peripheral devices. This will include your high voltage converter, your wireless repeater, and your REX. And I don't have it on here because I forgot to send it as part of the video submission, but the range test kit as well. I want mentally noted on this screen. So the high voltage converter is going to take 12 volts, or I'm sorry, it's going to take high voltage and convert it down to low voltage, which is 12 volts and 2 amps. The part number for that is the HVC. The wireless repeater is going to strengthen the wireless connection. In other words, it's going to repeat the signal maybe between 2 controllers to strengthen the connection between otherwise 2 very weak controllers. That is going to be the M&R. Then we have the REX, and the REX has recently undergone to a new part number, which is the REX HP, high performance, and it is that one that you see there on the screen. So it's not that slightly rounded one that you are probably used to. It's now that one on the screen. And then we have the range test kit, which is the RTK, not listed here. Just reach out to your sales rep if you do need one of those. Anytime you are doing wireless installations, you should always, always, always do a range test. All right, so some best practices. If we are doing multi-site, we will need to take into consideration that we may need to get more than one cloud node. It's previously been the case with PDK that you would do one cloud node for each customer, but now you can do multiple cloud nodes for each customer in a multi-site configuration. So if you have multiple businesses for a customer, or if you have multiple geographical locations for a customer, you will need to install a separate cloud node per site, per network, in other words. Even if you have the same customer and maybe they're just in several different buildings, if those buildings are on different networks, you'll get a different cloud node per building. We also need to consider if everything is centralized or distributed. In other words, is it an edge application or a centralized application? If your equipment can all be hosted centrally in an IDF or MDF, great. That's probably a centralized installation, especially if the infrastructure is already there. If that is not the case, maybe it is a site takeover, or they haven't previously had access control, or they perhaps don't have the, something very surprising to me has been always the historic buildings, how little leeway that you have with historic buildings. Those may end up being a distributed or an edge installation, in which case you'll need to get multiple smaller controllers significantly closer to the door, in which case it may end up making more sense to either do a PoE or a wireless installation. Finally, our communication, which is also going to be determined by the previous two components. We have our PoE or Ethernet, again with the limitation of that being our 100 meters, or wireless, which will be dependent on the results of our range test. All right, that is it for this presentation. Now, I do have a video that I am going to have pulled up by one of our integration partners, and they are going to cover, they provide a really unique solution. They provide a software that you can utilize to help you with your site design. Now, of course, the goal of my video is to assist you with site design, but there certainly are tools out there which will help you and assist you with the process. So go ahead and pull that up.
Hi everyone. In this video, we're going to be reviewing how to use System Surveyor alongside our manufacturer partner, PDK. Now, System Surveyor is an easy to use mobile system design platform that's cloud-based. So first, you can use it out in the field on an Apple or Android tablet to get the data you need. Then once you get back on Wi-Fi, sync it to the cloud so everybody can work out of a single collaborative platform. Now, to get started, all you're doing is uploading a PDF, JPEG, or PNG, or you can use our Google Maps integration. And last, you could use our Quick Start option, which has some light drawing tools to allow you to get a floor plan in place. Now, once you've got that floor plan, all you're doing is picking from the different system types on the far left. You can see today we're going to focus on access control, but we give you a variety of systems so that you can put together a complete scope. All you need to do is select the system type you need, pick that icon. So in today's example, we'll look at the components of a door. And if you're going to put a card reader in there, maybe a Rex, and then an access controller too, all you're doing is dragging and dropping those into the door to build out that door package. Now, the nice thing about PDK and our partnership here is they've done a ton of this work for you. In the platform, you can go ahead and take a photo if you want to of some of the different door components. So if we want to hone in on this locking mechanism, we're going to use an office door in today's example. You can do that, then you can annotate that picture with icons, shapes, or text. Anything that's going to give you, your install team, or the customer context behind what goes where. And then if you want to track some other information, you can do that here too. You can talk about door materials, you can talk about the frame construction. There's a fair amount of different attributes there for you to use. But when it comes to the functionality of the devices, this is where PDK has already done all that work. You can pick from a drop-down menu of all their devices. So I can select the keypad mullion prox reader here. The data sheets are going to populate. Most importantly, that model number is going to populate. So when we pull our bill of materials here in a moment, it's going to automatically be ready for you and be accurate. And then if you want to add any accessories, any freeform notes down there in the bottom, you can do just that. You can see here that the Rex, the access controller, all that really functions the exact same way. So for this controller, if I select red 4, same thing. The SKU populates, the functionality is all filled out. Again, PDK has gotten that in a place where they've made your job a lot easier. So let's say you've done the site walk, you've tracked all the information that you need, you're good to go. All you need to do is save this on the tablet, and then I'll move back to the desktop so we can look at a few different ways we allow for you to collaborate and continue that sales process. First of which is going to be guest user access. So if you want to come in here, you can add maybe a subcontractor who's helping you out doing a little bit of work. Maybe it's a PDK rep or a distributor rep who you're working alongside. If you invite them and give them either edit or read-only permissions, they can come in with their own login and you can all be working out of a single source of truth in real time. And we talked about the bill of materials a fair amount too. That's the most commonly used report here. I've pulled an example, as you can see. That make and model number are done for you. Any accessories you add pull through too, and that quantity is accurate. So you're getting a bid back much, much quicker than before, eliminating that traditional emailing back and forth, confirming part numbers, counts. you've got everything you need in one document. The other really commonly used report is our floor plan with legend report. This is going to include really the work that you just went out on site and did. It's a great way to convey the scope with a small key on the right-hand side. It's a great deliverable to be able to send out to a customer as a follow-up after you've gone out on site. Now, to get started with System Surveyor and PDK, all you need to do is go to the PDK System Surveyor landing page here. If you enter your information and sign up for a free starter account, there's no expiration date on that plan. It's a great way to test out the platform and make sure it's a fit. And then to download PDK's catalog files, all you need to do is click here. And then lastly, watch that video tutorial that'll really quickly walk you through how to import their products into your device. If you have any questions at all, please reach out to sales@systemsurveyor.com, and we're happy to help. Happy surveying.
Pretty easy, huh? I love that you can simply assemble everything together, put it all on a blueprint. I'm very visual, and then even better, put together a bill of materials that you can take to your distributor to then get you the requested equipment. Now, as promised in the chat, we are going to have a pop quiz. I'm sorry, we are not yet out of middle and high school yet. I am your teacher, and today we will be having a pop quiz. So, Jordan, if you would like to pull those up. All right, we are going to go through 4 scenarios. Scenario 1, and let me walk you through how we're going to do this, because we were trying to decide the best way so that everyone could contribute and have time to design their scenario. So what we're going to do is I'm going to go through 4 scenarios here. I'm going to walk you through the important components to each, something typical that you would design during a site walk, or information you would retrieve during a site walk, rather. And then you are going to jot down in the comments what equipment you would use for each of these sites. There's no right or, well, there are right answers, but just put down whatever you're thinking in the comments, and we're going to walk through each of these scenarios with Cole's solution at the end. The reason I say Cole's solution is because there are typically multiple ways that you can design a site. So I guess kind of what I was trying to get at is that while there are right answers, there are multiple right answers with this. Yes, Tyler, a pop quiz. All right. Scenario 1, we have one building. It is simply 5 doors. They're scan-in doors only. The client has requested to be as budget conscious as possible, so prox credentials. All indoor entrances, and an IT closet is central to all the doors. And we're going to presume that there is wiring already run to each of those doors. Next scenario, we have a building, which is a warehouse. It has 8 doors, which are scan-in only. They also requested prox credentials. This is going to be a combination of interior and exterior doors. There's no IT closet, only an admin office. The point I'm trying to get across here is that there is nowhere centrally to install equipment. Keep that in mind when you're designing this. No existing CAT cabling, too expensive to run. No existing access cable, lock and key existing only. So pick up my subtle hints here, all right? Everything is too difficult to run Ethernet cable. All right, scenario 3, we have a storage facility. There are 3 entrances. There's 1 gate and 2 doors. There's no trenching to the gate. That's very important component number 1. There's no internet or infrastructure on site. Bluetooth credentials have been requested. There are exterior doors only, and there is a scan in and scan out at the gate, which means that you will need 2 relays. Spoiler alert. Scenario 4, we have a business park, which has 5 separate buildings, but they're all managed by the same company. All right, so remember back to when we have multiple different networks within the same company. Remember what that meant. Separate networks for each building. Building 1, 3, and 4 have 20 doors. Buildings 2 and 5, there's no 6th, 36 doors total. They have a desire for high security, and each building has an MDF. All right, that means that they have somewhere central that they can install all of these devices. I don't see anything coming through yet, so I'm going to give people a few minutes to type things out. Go ahead and start with scenario 1. Again, we have one building, 5 doors, prox credentials, all indoor entrances, and an IT closet central to all doors. If you remember back to our 5 essentials, we have number 1, which is the cloud node. What kind of cloud node will suffice for scenario 1? Number 2, we have our credentials, controllers. They all sound the same. Your controllers, how many doors do you need to control? And keep in mind that the RCNE and the RCNEW both have a single door controller on board. Then we need to consider our readers, prox credentials, so which readers support prox credentials. And then number 5, which prox credentials do we opt for? We have several options to choose from. And finally, number 5, we need to consider our peripherals as well. All right. Let's move into scenario 1. So scenario 1, we have our head-end unit, the RCNE or the RCNEW. Both of those will suffice. We have one being Ethernet only and one being wireless. So that covers necessity number 1, which is the head-end. Number 2, controller. I put in R4. There's the IT closet centralized to all of the doors, and that means that we can install all of the equipment centrally. So I opted for the single door controller on the cloud node and in R4 to cover the remaining 4 doors. There we go. We have like a 30-second delay, so I'm really trying to stretch this out. If you're listening to this right now, start putting scenario 2 in the comments, because we need that 30-second delay and the typing delay that it takes you to type them all out and brainstorm. Also do scenario 3 and 4 while you're at it. Just do all of them. Put them all in the comments. Anyways, where was I? The RDRM and RDRG, that will cover our readers. So we need 5 readers because we have 5 doors. They're all scan-in only. So we can do an RDRM or an RDRG for each door, and that covers necessity number 3, which is our readers. Then we have our credentials. We have a lot of options to choose from here. The ones I opted for are either the CPC, which are the printable credentials, the CSC, which are the clamshell credentials, and the KFC, which is the key fob credential. So that will cover number 4, which is our credential. And then finally, we have our peripherals, which are going to be the REX or the high voltage converter, if needed. I put those down on all of these just in case we do end up needing any of those. So you'll note that all 5 necessities have been met: the head-end controller, reader, credential, peripheral. If you have met all 5 or have considered all 5 of those necessities, you probably have a full configuration. So I'm going to go ahead and read scenario 1 out of the comments here. JR, 1 RCNE, an R4, 5 RDRMs, CSC. Textbook, classic. Good job, JR. T-Data, scenario 1. The red node, yep. The red 4, yep. The 5 RDRMs and all necessary Cat5e cables, and also an AL800 for strike power, and allow for FACP shutdown if necessary. Holy Toledo, you are on it. I don't know who you are, but you did a good job. You did a very good job. All right, getting into scenario 2, JR has already beat us to the punch here. Number 2, RCNEW, 8 R1s, 8 RMWs, and that's covered by the heart icon, which is super obnoxious. Let's see, RDRM and 8 REX HPs. So Jordan, let's move into scenario 2. Excellent job, JR. So we have one building, which is a warehouse. The 8 doors are isolated, no cat cabling, and they're too far away. And this is, I tried to make it very obvious by the way I phrased the scenario 2. We need to do wireless. So JR is absolutely correct. We need an RCNEW. The RCNEW is the only cloud node that supports wireless. Now, you also mentioned 8 R1s. Spot on, that's just what I was thinking. Now, importantly, the R1s come as Ethernet by default, so we do need to make sure that we get those wireless modules as well, which is the RMW, the Red Module Wireless, for each of those door controllers. Not just one RMW, 8 RMWs, because we have 8 R1s. You mentioned the RDRM and the Rex HP. That's perfect. I actually put more ruggedized readers in this, and the reason being is because it's a warehouse. It's more industrial. That's just personal preference. That's not to say RDRM is incorrect, but that is my reasoning behind the MRS and the GRS, is that they are more rugged. And probably, presumably, a warehouse, a more industrial site is going to see more either crime in the area or more abuse to the readers internally and externally. So that was my logic for that. Credential-wise, I put CPC, CSC, KFC, BRC, or WBC. How many C's can you say that times fast? That many times fast. I put BRCs or WBCs, maybe. The employees at the plant need a credential that's out of sight and out of mind because they are working very hands-on with stuff inside the warehouse, in which case the BRC or the WBC, the wristband credentials, are going to be your best bet. And finally, we have the Rex HP, the HVC, and the MNR as needed. I would also note the range test kit. Do not do this installation before you have done a range test to make sure that the RCNEW is reaching all the way out to those door controllers. And I don't see scenario 3 coming through yet, so don't forget to submit scenario 3 and scenario 4 while we walk through this. So that covers all of your 5 solutions. MNRs might be needed depending on the results of the RTK, the range test kit, I should say. The high voltage converter would maybe be a perfect fit because that will reduce high voltage down to usable low voltage for us above each of those doors where we have the R1 and RMWs. And then the Rex HP may be necessary for egress out of those control doors. Yeah, sorry, Jordan. I'm not very good at multitasking. I was reading the comments. I shouldn't have. All right, scenario 3. This is the storage facility. Great job, guys. I see some stuff coming through here. Scenario 3, we have one storage facility, 3 entrances with 1 gate, 2 doors, no trenching to gate, no internet or infrastructure on site. That's kind of a trick question. Bluetooth credentials requested, exterior doors only, and scan in and scan out at the gate. So, number 1, first and foremost, we need a cellular router. I did not put that on my bill of materials because it is outside of the scope of what PDK offers, but some sort of cradle point or netgear, some sort of cellular component to take a wireless signal out of the air and produce it into a usable internet signal on site. You don't need a lot of data either. Typically, a 5 gig plan each month is more than sufficient, and it doesn't have to be very fast either. I think it's 5 megabits a second. It might be even lower than that. I mean, it's not a lot of data that you're going to be using for the solution. So make sure that you have a cellular component on site. Excuse me. Now, 1 R2 or 2 R1s. This is another thing that I didn't adjust correctly, but 1 R2, if we are going to run both of those doors off of the same controller, or we could do the RCNEW for the first one and 1 R1 for the second one. So that's a little bit of an error on my part, but it's dependent on the infrastructure, and it depends how far away the doors are from each of these. We have 1 to 2 RMWs for the R2 and R1s. And then for the gate, you have 2 options. You can do an RPW or an RGW. The difference being that the RGW is that plastic NEMA enclosure and the RPW is that steel enclosure. Since Bluetooth credentials were requested, I also spec'd out 4 red Bluetooth readers, which are any of those listed readers right there. You could also do the RKB or the RKPB if you don't mind having a keypad as well. Bluetooth credentials as needed, which means we technically don't even need any physical credentials, although you are certainly welcome to spec out physical credentials that work with any of those readers. And then finally, a Rex HP for those 2 doors. That wouldn't work for a gate. Keep that in mind. The Rex HP is designed for internal egress, not gate egress. You'd need some sort of induction loop, but you can tie it in to the system either way. A high voltage converter, again, if applicable, for the 2 internal doors. The gate is going to require significantly more than 12 volts and 2 amps. And then the M&R for the mesh network if you do need to improve the communication. Don't forget, range test kits. This one we're using wireless, so range test from the cloud node out to the gate. It's especially applicable with buildings like this where they may be made of cinder block or steel or cement or some sort of plaster, something that's hard for a wireless signal to get through. You really need to take care that you test the wireless environment first. So let me go ahead and read the scenario 3s here. And while I read these, don't forget scenario 4, which is that business park with 5 buildings and multiple doors at each building. In fact, Jordan, do you want to go back to the main page so people can see the scenarios? Thank you. All right, scenario 3 from Tyler. RCNEW, 2 R1s, perfect. RPWs, perfect. The red pedestal, or I'm sorry, just 1 RPW you noted here. So that's the red pedestal, opted for the steel enclosure mounted on a gooseneck. 2 RMPs, we would actually need 4 RMPs because we have the 2 internal doors and then we have a scan in and a scan out at the gate, which means even though we're only classifying 3 entrances, we need 4 readers. Oh, you put RGP next. Here I am like saying, oh, no, that's not right, and you were right all along. So RGP, you would need 1 more though, and 2 Rex HPs, perfect for the 2 internal doors potentially. Great job, Tyler. All right, number 3 from JR, RCNEW in R1 in RMW, so that'll cover your 2 internal doors. The RCNEW will cover 1, and then the R1 and the RMW will cover the 2nd door. We have the RPW for the gate, perfect. A wireless component out at the gate. 3 RDR MRSs, 2 Rex HPs, CSE, RTK. For that one, we would need 1 additional reader. We have the 2 internal doors and then the scan in and scan out for the gate. So that's a total of 4 readers instead of 3. But otherwise, absolutely correct. 2 Rex HPs, a CSC clamshell credential if needed, and an RTK if necessary as well. So hopefully all of you have had time now to look at scenario 4 and start to put your answers in the comment box. I'm procrastinating, delaying. We'll give it a few minutes. All right, so we are also going to have a bonus question at the very end of another scenario, but I'll give it just another few seconds for people to type out. It is a lot, I get it. That one's a lot to type into a chat box so quickly. All right, let's go ahead and get into it, Jordan. Scenario 4, and if you're typing, just keep typing. Don't even worry about it. Scenario 4, we have our business park with 5 separate buildings. They're all managed by the same company though. So this is going to be our key indicator that we need a multi-site configuration. Separate networks for each building. Building 1, 3, and 4 have 20 doors each. Buildings 2 and 5 have 36 doors each. And they have a desire for high security. And again, these are all centralized MDF. So here's my solution, and I'm going to kind of walk you through how I got here. Again, if you are still typing, don't stop typing, keep going. I want to see what you came up with. So I spec'd out 5 RCNEs or 5 RSVRs. It is typical with some of these bigger office buildings that they already have an IT rack that they want to mount everything inside of, in which case just do an RSVR. Otherwise, you can do an RCNE, which will cover each of these buildings. Now we're jumping into the big guns here. We're going straight to the red max. We're not playing around. So buildings 1, 3, and 4, 20 doors. The Red Max is capable up to 24, so we fall well within the range of what the Red Max was designed for. So I did 1 Red Max and 3 R4Es, because if you remember, the Red Max only comes with 8 doors of control from the factory, so we need to add an additional 12, which means we need 3 R4s. And the expansion boards for the R4s are the R4Es. All right, makes sense there? I can mentally see you all nodding. All right, 1 R max for buildings 2 and 5, I should say. 1 R max. We're going to have to fully cap these out because the Red Max again only goes up to 24, and we have 36 here. So 1 Red Max with 4 R4Es. So that gives us a fully spec'd out Red Max per building. Now on top of that, we need to do either another Red Max and do 2 Red Maxes with a total of 7 R4Es, or probably a cheaper approach would be to do an R8 and an R4, and that'll give us a remaining 12 controllers that we need to get to 36 doors. So you can see my solution below as an alternative if space consolidation and keeping everything within the same enclosures is a primary idea for you. Be sure to do just 2 Red Maxes. That's totally fine. It probably won't be quite as cost effective, but if you did 2 Red Maxes with a total of 7 R4Es split between the 2 of those Red Maxes, then that would keep everything consolidated to just 2 enclosures. We'll need a total of 132 red readers for everything. And keep in mind, those Red Maxes, R4Es, Red 8s, Red 4s, that's per building because we need to accommodate the 36 doors total, which is why we have now such a big number, 132 total readers that we need. The reason I went with the red readers is because they had requested high security. So we want both the OSDP and either the 13.56 or Bluetooth credentials to meet that. So 132 red readers of whichever variety we choose to meet our credentials, and our credentials that we will use will either be smart card or Bluetooth credentials. Which of those credentials we choose will determine which model of the red readers we go for exactly. So you can kind of alternate between the readers and the credentials to decide what your bill of materials, what your final bill of materials will end up being. Now, since we're not dealing with wireless, we don't have to deal with the repeater or the range test kit. So now all we need to consider is the REXs, the REXHP, and the high voltage converter. And realistically, the high voltage converter is pretty much useless for any of these except the RCNEs. The R Max comes with those 2 Altronics power supplies, which is going to do way more for us than these high voltage converters will. But since the cloud node itself doesn't come with its own Altronics power supply, maybe you might need HVCs for those cloud nodes. Maybe not. I mean, we provide the transformer with the cloud node, so if you just use that transformer, no need for anything else. All right, bonus scenario. All right, we have an apartment complex with 4 separate buildings. Buildings 1, 2, and 3 have 3 doors each. Building 4 has 12. All doors are indoors. We have a shared network with single management between all of the apartments, and we have each building with network access, and the entire campus shares the same network. Each building has an IT closet, and there's a strong desire for high security. So my solution here, I'm actually going to add something else into the bonus scenario. Let's suppose that buildings 1, 2, and 3 have an elevator as well. So starting with our head end, going through the 5 essentials, so working down from the top, head end unit, RCNE. We don't have any wireless. I didn't see any need to put an RCNEW. Some people choose to do an RCNEW even if they don't need it, simply because it provides a future-proofing option if you do decide to ever go with wireless. So for buildings 1, 2, and 3, I put 3 R4s, and that would technically be overkill because we only have 3 doors per building, but that gives us an extra slot to work with. As an alternative, I put 1 R1 and 1 R2 per building for buildings 1, 2, and 3. That would be more expensive, actually. It does give you exactly as many slots as you need, but buying 2 separate controllers as opposed to just one is a more expensive option. Now, if we were doing an elevator in each of these, we would probably need to go with the R4 so that we have a spare slot for the elevator reader. And then we can get the aux 8 for as many floors as we need. So let's suppose each of these buildings has 6 floors. We could install the reader and the second floor technically on slot 4 of the red 4, and then we can put the remaining floor relays on the remaining ports of the aux 8. I hope that makes sense. Basically, we need one reader port to control the reader for the elevator, but then we also need additional relays, just not readers, for each of the floors that we will be controlling in the elevator. So we can just do that by adding in an extra aux 8 and A8 to each of these buildings. Building 4 with its 12 doors is going to be a little bit bigger. So I put down 1 red 8 and 1 red 4 for building 4. Alternatively, you could do 3 red 4s. You could do 12 R1s. You could do 6 R2s. You could do a whole lot of things. You could do a red max if you wanted. I think that would be a little bit much, but you could certainly do that as well. Your red readers, since we have a strong desire for high security and or mobile credentials, I spec'd out the red readers and the Bluetooth or smart card credentials. And then since we're not dealing with wireless here, I put a Rex HP and an HVC. All right, I think, just reading the comments here, I think we are all good to go. So let me go through. If you guys do have any questions, please drop them now so that I can read them. I am going to go through and make sure I didn't miss any of you that put your scenarios out there. So, JR, RCN, we read that one. T-Data, you did awesome, great job. JR, the RCNEWs. Bernie, my guess for wireless for scenario 3 was good. Great, good job. And it sounds like you're new to this and catching on quickly, so I'm glad to hear that. Any other questions as I'm scrolling through here? Let's see, does your wireless network use the same frequency as Zigbee's? Mike already answered that, 2.4 gigahertz and 802.15.4. All readers can use the phone to open. That is correct, to a degree. So we've got our 2 kinds of mobile credentials. We've got the Bluetooth and we have the mobile app. Bluetooth requires a special reader. The Bluetooth requires a special antenna inside the reader to read the phone's Bluetooth signal and open the door. The other one, though, is not communicating to the reader. It is communicating to the controller directly. That one, you could use HID readers for all we care. It doesn't matter to us. We are directly opening the relay from the phone app. So any kind of reader will support one of our credentials, but only specific Bluetooth readers will support the other kind of mobile credential. That's a very good question. Thanks, Miguel. Where do I go to find the engineering diagrams for wiring? Reach out to your sales rep. They should have them. If they don't, they'll reach out to me and I will send it to them. It's just the red engineering diagrams. Oh, and Ryan answered that for me. There are some wiring diagrams in the knowledge base, even better. Here Ryan is saving the day. He always comes in clutch. Power supply for RSVR. The power supply is built in, so we send you one of those big, thick cables that plugs directly into a wall outlet. It's a standard connector. I can't remember the name of those connectors. The same one you use on every desktop PC, the high voltage plug-in and the transformers inside the RSVR itself. All right, I think that is all the questions. If you didn't get around to asking your questions, reach out to the sales team. Their information's right here on the screen. They will be happy to help you out. Alternatively, you can reach out to them at 801-317-8802 if you like to talk to people in person. I know I do. And they would be happy to help you out with sending you the engineering diagrams. And you'll notice if you call in, Their information on the phone says that they are sales and site design. The sales team is here to help you out with site design. I have helped more people than I can personally count with niche site design situations. We always come across them. I strive to cover them in today's scenarios, but there's always going to be some unique circumstances that you may just need PDK to help you out with, and that's totally fine. So reach out to the sales team, and they would be happy to help you design your next site. So until we catch you next time, this has been the Access Control Coaching Session. Our next one will pick up in January, and that one will be sales focused. That one's going to be very exciting. So happy holidays, everyone. We'll catch you next time.